Hello, everyone. My name is Stephanie Boozer. I'm with CUGC HQ, and I'm happy to welcome you to today's webinar. We're going to be talking about Citrix Virtual Apps with NVIDIA Virtual GPUs and the system impacts of that. But before we get started, I do have just a couple of quick announcements for you. First of all, I just want to make sure that if you haven't been out to mycugc.org, that you go out there today and take a look around. We have local groups all around the world. They meet regularly in person, and they're great events for you to go to and get connected with your fellow Citrix peers. Ask for advice, share advice. It's a great way to get connected. Also on our online community, we have lots of expert blogs with great technical information and forum discussions. So if you have questions, you can ask those online and you can even help other people out. So definitely come by and visit today if you haven't already. Also want to let you know about a couple of upcoming events. Tomorrow is the Citrix Employee Experience Virtual Summit. It is a full day of technical sessions, keynotes, all about how to power a smarter and more flexible workplace. And definitely come by and see us in the CUGC virtual booth. We'll be there all day, so love to have you stop by and say hello. And also don't forget that now is the best time to buy your Synergy Pass for 2020. This is the best price you're going to see. It's buy one, get one free. So it's the season of giving. So definitely consider that if you have a friend, a colleague, or even a CUGC buddy that you want to share the BOGO price with. This is a great time to do it. All right. Today, our presentation is being recorded. You will receive a link tomorrow to the recording. That email is going to come directly from GoToWebinar, so be on the lookout for that. And we'll also have other resources in that email for you as well, because I have some links we're going to be sharing with you today. Also, just want to invite you to submit your questions as you have them. We're going to take time during the presentation to answer a couple of questions during some breaks, and then we'll save the rest of the questions for the end. But do type in your questions as you have them so you don't forget them. And finally, at the end of the presentation, I will share a link to a survey, and it's for CUGC use only. It's anonymous, it's very short. We just like to get your feedback. All right, so before I hand things over and to introduce who's on our call with us today, Hendrik Meier is a Citrix technology advocate and a senior systems engineer for Citrix. He has more than 15 years of experience with Microsoft and Citrix products and has a wealth of knowledge. He's published several books and articles about Citrix Virtual Apps and Desktops and NVIDIA Virtual GPU. So I'm happy to hear from him today. With him is Ronald Grass. Ronald is a senior sales engineer with Citrix in Germany, and he has also got extensive knowledge with NVIDIA. So he's a member of the NVIDIA Grid Community Advisor Program. He is a subject matter expert, and I think that we are in for a really great presentation today with both of these guys, with lots of great information coming your way. So with that, I'm going to hand things over to them to get us started. But in the meantime, I know you already answered one poll question. So while Jan is getting his screen set up, I am going to kick off a couple more polls for you just to get a little bit more information about where you guys are. All right, Jan, the screen is coming your way. And I'm going to kick off another poll.
Did you give me the presenter right?
Yeah, I think it's I sent it. I think because the poll's up right now. Just give it just a second. You guys can go ahead and say hello while everyone's answering their poll questions.
Yeah, hello everyone. I've seen a couple of people I know already all over the planet, from Austria to Germany, UK, US, and many more. Hi from cold Germany here. So waiting for the poll to finish, and then we'll start from our side.
Welcome from my side as well. Good morning, good day, good evening, whatever time it is for you. Thanks for joining. So looking forward to an hopefully interesting session for you guys.
Okay, great to see. Mostly still Maxwell based, but the others are coming as well, or do not use, currently do not use GPUs. Okay, maybe we can change that. Okay. It's okay. Is it working for you? So we can start, and I think we can skip the first slides because thanks for the introduction. I think from my side we can skip this slide. We have been introduced as well. So yeah.
Yeah, just one little point I would like to add. Some of you might have heard about the virtualization communities in Germany. So there are several people organizing communities around virtualization in different areas of Germany, and luckily I'm allowed to organize the one in Hanover. So if you're somewhere nearby Hanover, look for the VCNDS, and we have an appointment which you might like to join. Next to that, as Jeff already mentioned, I published several books in the Citrix and NVIDIA area in the past. So if you like, you can still have a look, but don't focus too much on that. Let's continue with the actual parts.
Okay, so then let's start with the basic. A very basic formula, but very complex one. It's not that complex with vGPU or GPU virtualization as a whole. We will talking today a lot about NVIDIA because the majority of our customers at least use NVIDIA. So in the poll you see other options to vote for, like AMD, for example. As I see, only 6% right now are using AMD Fire Pro, Radeon Pro. So this will focus around NVIDIA technology. So, but some of these basics I'll like to cover are very similar to both. Nevertheless, what kind of GPUs you are using. So unfortunately, it does not click for me. Can you please click, Hendrik? I can request mouse. Okay, thanks. Good to go. I cannot request a mouse cursor and keyboard, but anyways, so it's about lessons learned, and I had to learn a lot of lessons the hard way because when I started with all the technology around 2012, 2013, when it's alpha to beta status of GPUs, virtualizing GPUs, it was a lot around setting the right expectation. Many of our customers out there have a wrong perception of what they can do and achieve with that kind of technology. So make sure they have the right expectation and adapt the technology to their use cases or to your use cases if you're an end customer. If you are a partner, there are another things like lessons for example. You need to have experience in both, in the GPU and the virtualization way. So it's a combination always of technology between pure virtualization, pure Citrix stuff, and GPUs. It's totally different in some of the spaces, and you need to be sure to talk to the right people, setting the right expectation, what can be achieved, what cannot be achieved, what is possible, what's not, where are the limits, and you get that by experience. So building experience, doing projects, building some rigs, playing around with it, and you still need to know your application, which was lesson number 2 for me. You need exactly to know what your application is doing, what APIs they are using, how they are working. Are they more single-threaded? Are they multi-threaded? Do they use single GPUs, multi-GPUs, which is possible right now, which wasn't a long time available. But you need to know how your applications are working to choose the right profiles, to choose the right GPUs, to choose the right solution. Is it XenApp or is it a VDI? And you need to know exactly what applications are doing, and mostly the CAD/CAM guys or from the disk space, for example, for geoinformation systems, PACS, medical imaging. They all work differently, but you need to know how they work and talk to the product owner or product specialist from that perspective. Another thing which I learned, and a lot of people did wrong in the past, they had wrong assumptions. They thought, I know the application is doing this in that way, and they didn't do a POC, bought some hardware and thought it would be good, but it wasn't. So please, please, please always do a proper POC with real world scenarios, not with some artificial synthetic benchmarks or something. Please test it in your real environment with live data and all that kind of stuff. That will help you a lot. And last but not least, feedback is very, very, very valuable. So please feedback to us, to Citrix, to the community, share your insights, share your knowledge, so we can leverage that, learn from that. It's very, very important to us. So can you just click, please? Okay, and we are on the next topic here. And knowledge and experience are the key. There are a lot of books. You see the one Hendrik wrote, for example. You see some setup guides, some white papers, some blog posts. There are good guides out there. The NVIDIA documentation is great in my eyes. There are performance white papers and all that kind of stuff. You can really, really consume a lot from the internet, from the different sites, maybe the manufacturers or the software vendors, the OEMs. They all have great documentation, white papers, performance white papers, integration white papers. Use that, learn from that. They are really, really great, and please leverage that, what others already have learned and shared there. So, okay.
So when you look at the different topics, you first need to decide which GPU type you're going to choose. And if you look at NVIDIA, they offer a lot of different ones. They started with Kepler, followed by Maxwell, then Pascal, Volta, and Turing. If we take a deeper look, you will see there's a lot of data that you need to think about and that you can compare. So it's not like, okay, go to a shop and just select this card. It really depends on the use case and the workload you have. So you need to consider a few topics when you choose your card. So for example, if you look at the M10, the M10 is a card for a dual slot, but on this card, there are 4 GPUs available. On the other hand, you have like the T4. It's a single slot card, but only with 1 GPU. So if you think about it, on a slot with an M10, you have 2 GPUs. On a slot with an T4, you only have 1 GPU. Next to that, there's the power consumption. If you compare like the P4 with the P40, the P4 only is 75 watts, while the P40 has 250. So a lot much more power, which you need to get into your data set, into your server. So you need to much properly size your power supply for the server itself. Another point which the cards support differently is the size of the vGPU profiles. Also, it's another topic if the 0.5 profile is really useful, but only the like older cards still support it. And in contrast, neo cards support bigger profiles with like 16 gigs. You now already see we have like on this slide 7 cards available. You can easily continue this if you dig into compute workloads and combine them. So then you have other cards that you need to think about. They are not really typical in vGPU scenarios, but like Johan van Amersfoort, who is doing often combined workloads, those VDI by day, compute by night, then you start to think about these cards. So then you need to look at them as well and have more details of planning which cards to choose. When you've chosen the cards, it's not all. You also need to decide which type of software you're going to use, because NVIDIA doesn't only request you to buy the graphics card, they also expect you to buy a license for the graphics card. So in the past, you had the Virtual Apps license, which was like mainly for Citrix Virtual Apps or HEVC. It's a little bit confusing because it's named Virtual Apps, but also means published desktop from Synapse, classically named. Next to it, you have the virtual PC. The virtual PC license is for desktop computers, the normal office workers, so no complex CAD workload. And then you have this fancy name, Quadro Virtual Data Center Workstation Edition. And that is for the high-end graphics users, which require specific functions to integrate. And lastly, NVIDIA has added the licensed virtual compute server. So as mentioned before, you can sometimes combine the VDI workload with the compute workload, and then you need a license for the compute stuff as well. Ron, it's up to you. Good your configuration.
Yeah, I can hear. Yeah. Okay, so can you click once? I can't click, unfortunately. So, okay, yeah. So there are several configuration you need to make sure you set the right properties and the right settings, because as you know, maybe the Tesla cards have not been initially made for vGPU and virtual GPUs and to use it in VDI or remote desktop session host Synapse. So they have been made for compute, and basically the M60, for example, the Maxwell-based cards comes in compute mode. The M10 was a purpose-built VDI card, which is already or have already been shipped in the graphics mode, and you have to switch the cards if they are not in the correct mode via a small tool, the GPU mode switch, which can be used when booting an ISO file on your server. Maybe if you have already a GPU manager installed and it won't let you run the GPU mode switch command because it interferes with the installed vGPU manager. So boot it up from an ISO file or on the Xen server it works, and with ESXi, so vSphere it's not working. So you have the possibility to boot it from an ISO file, for example. So you can check it, which mode is currently used. If it's compute mode or it's the GPU mode, you see it by issuing the lspci command. And there, what you see is a mixed combination. So not officially support to mix cards of different generations or different types. For example, as you see, P4, P40, and M60. It was my test server. It works, but it's not supported. And as you see, the Pascal-based cards do not need to be switched. That's another topic on the next slide, please. You have to make sure another setting, which is there is the ECC setting. For example, back in the days before vGPU 9.x, so in 8 and below, ECC must be disabled because the driver was not able to cope with the enabled ECC. It's about all the Framebuffer configuration and how it gets calculated and passed through with all the base address register and all that kind of stuff. So please make sure if you're still on the version 8.x or below to disable ECC mode. I can only what you see here is if you have it enabled, you can't start virtual machines, and it's some very strange thing there. There's normally you have ECC mode 1. You think it's enabled, and 0 it's disabled, but it's not. If it's 0, it's still enabled. It needs to be show you the off, as you see it there, not 0. It must be off, and then it's definitely be disabled. And I can tell you if you don't need it, you can use it. You can disable it by issuing NVIDIA SMI command, NVIDIA SMI -i, and then the bus ID, or if you want to have all, only you need -e and then 0. That's the strange thing. You issue 0, but you see it off afterwards. You need to reboot the host. That's very important. And for vGPU 9 and above, you can leave it enabled. Can you please click, Jan? I wouldn't recommend to do it because you don't have the same amount of Framebuffer available to the vGPU. It's reduced. It's documented in the NVIDIA docs, as you see the link below. So it can only be enabled for Pascal and Tesla cards, so Pascal and Turing cards that needs to be there. Well, this should be work as well, but I didn't test it already, but I tested it with Maxwell. Although it was stated it does not work, I learned it the hard way. It does not work if you re-enable it after issuing the GPU mode switch command, which effectively switches to graphics mode and disables ECC. If you enable it by hand afterwards, it will crash the whole host. So not recommended. Please don't do it. You need the support of the hypervisor, that ECC is usable for all the pass-through stuff and the MMIO stuff. So you don't need to reconfigure the new cards, and ECC is only available for the Q profiles, for the Quadro Data Center Virtual Workstation profile and the C profiles, so compute profiles, not available in B and A profiles for XenApp, remote desktop session hosts, or the virtual PC. So only C and Q profiles are supported. But here's a table in it. It's we don't do a test afterwards, so it's just for your reference, which can be enabled, which should be enabled, and how you can run it. We can skip it, I think. It's just for your reference. Okay, one very important thing I would say is about the scheduler modes. They can have a huge performance impact if you choose the wrong one or you don't use the right one for your use case. There are different schedulers. For example, best effort scheduler is now the default scheduler again, which hasn't been the default for grid 5.x. It has been in 4.x, for example, it was equal share. And so what you can say, best effort is tries to balance the performance across all vGPUs and to use the GPU cycles which are not used by other VMs and recycle them, I would say, and give it to other VMs to have a best GPU performance. But it brings a very negative thing into it, and that is the noisy neighbor problem. If you have one application which is behaving not well because it wants to render 1,200 frames, whatever, you can end up. So what NVIDIA did in that case, it introduced the frame rate limiter by the vGPU manager and the driver, which tries to eliminate that problem. It cannot be guaranteed that it's not happening. That's why, for example, CUDA was not or is not enabled and cannot be used with the Maxwell cards because they don't have any hardware preemption, for example. But for me, it's still the best scheduler if you stick to the frame rate limiter, leave it enabled, and you can use the full potential of your GPU. If you say you want to achieve an equal share, so each booted machine, each booted VM gets its fair share. For example, if you boot up 4 VMs, every VM gets a quarter of the performance. If you boot up 3 VMs, it's a third. If you boot up 8 VMs, it's an eighth of the whole GPU power which is available. So that is it gives an equal share to each VM. Therefore, you need at least a Pascal generation or later, because they all have hardware preemption and can say, VM, please stop. I need that time slice for another VM. And the last option is the fixed share scheduler, which in my eyes is only for cloud hosting, where you need to achieve a given quality of service. If you buy 1/8, you get 1/8. If you buy 1/4 of a GPU, you get exactly that quarter, no matter if 8 or 16 or whatever VMs are booted up. If it's only 1 or 10, if you bought 1/16, for example, you get exactly that. That's fixed share scheduler. Not suited for most environments, but if you need to assure quality of service and deliver exactly what has been promised to the customer, you can use that. So please, for normal workloads, I would stick to the best effort scheduler. Maybe equal share. Fixed share is very, very rare to see. Okay, we can go to the next slide, and I think it's over to you, Jan.
Yes. So as you've seen before, we had the different options when you select a GPU type. Every GPU offers a different amount of frame buffer, which is the system or the memory for the graphics card. And you also assign an amount of frame buffer to each VM that uses the graphics card. So what we did is we did some tests to see what are the influences on the frame buffer and how does the graphics card behave with the frame buffer. Because a lot of people in their planning don't think about the frame buffer. They just assign a slow size of frame buffer and don't know what the effects are. So what we did is we had an environment with a CXAN server and a Citrix Virtual Apps, so a classical terminal server running. And we also used the NVSI workload. So for some tests, we used the knowledge worker with really limited applications. So personally, I think the multimedia worker is more the general office user today because it contains video and Google Earth, so small 3D applications. So we started our test and had a look onto the CXAN app to see how the system behaves when we run these applications or this workload. As we wanted to see how the GPU especially behaves, we didn't use the NVSI metrics to cover the data. Instead, we used the GPU profiler. So we started with a P4 and a 1 gig profile. And what you can see with the light blue line is that it, at the beginning, starts really early to get up to a high usage of the frame buffer. So here below, you can see with the light gray line the number of users connected. And it's like the second user connected and the third user and the fourth user, and the frame buffer is already at a 90%. And what is important to know that the GPU never uses more than 90–95% frame buffer. When it reaches this frame buffer situation, it starts to swap over the frame buffer to the normal system memory, which results, which you can see later, in a really high GPU usage because of swapping all the frame buffer to the system memory. And also the CPU gets more load to handle all this offloading. So we switched it to P4 with an 8 gig profile, and you can see the whole looks much more relaxed. The frame buffer just climbs slowly up, but it's not like blown up completely. If you have a look side by side, it's much more clear where you can see the difference. So on the left-hand side, you have the 1 gig profile, where the frame buffer is nearly like 100%. And on the right-hand side, you have the 8 gig profile where it just gets up. So just this workload and logging on users, the frame buffer gets really easy loaded quickly. And it has a big effect on the GPU usage, which you can obviously see. Another point we tested is like NVENC. So for those of you who don't know what NVENC is, NVENC means that we offload the H.264 encoding, which happens on the VDA, to a special chip on the graphics card. So we wanted to see what happens if we get a better system usage or how the system behaves when we change it. The first point you notice is that we now see the encoder on the left hand. It's the yellow line stays at the bottom, and the right hand you see it's getting some load, but it's not really under high load. Even with 15 users, it's still like okay, it's running somewhere down. But on the other hand, the frame buffer has like 20% more usage. So with 15 users and without NVENC, you have like a 50% of frame buffer usage. Or with more users, it gets up to nearly 70%, just because you enable this or a separate function. So we really need to consider this. On the other hand, the GPU usage itself keeps quite the same because it's a separate chip, so it shouldn't have a big effect on the GPU, as we normally do the H.264 encoding on the graphics card. Another point we wanted to have a look at is what happens with the screen resolution. So if an full HD monitor or two HD monitors. So what we did is we did some more testings with a full HD monitor and with 2 full HD monitors. We had extended VM again for vCPU, 16 gigs of RAM and 15 users. To make sure that there's no one-time exception, we also rerun each test 3 times and compare them, so we make sure we have like a valid usage. Ron, could you mute yourself to disable the typing? Sorry. So what you can see is with a full HD monitor, we achieved the 15 users, so 15 users are running. But on the other hand, you see that the normal system memory gets around 80% usage. So if we take a deeper look, and even the Framebuffer is around 80% usage. So it's quite nearly saturated just because using a full HD monitor. What's interesting to see is that the Framebuffer usage just climbs like a line up. So there's no big like going up, down. It's just like climbing up, more users, more applications running, and just going straight forward. And you can see the top of the Framebuffer is 88%, which means it's nearly fully saturated. If we now switch this to 2 full HD monitors, you can see that we are much more early at the system memory of 80%. So we reach much more early that the system memory is at 80% and it just goes higher. And what's also interesting to notice, what you wouldn't see normally when you don't know it, is that the 15 session is not started. It's marked as like someone is starting a session, but the session just fails to launch because not enough resources are any longer available, because the other 14 users consume now so much system load that it's not enough for the other users. If you have a look at the session number shown here, it's 19. It's a little bit confusing, but you always have some like idle session, waiting sessions on a remote host available, and a admin session connected. So you have like an admin session, which is 18, and then you have like 4 other sessions running in idle mode.
I think my audio dropped. Hope I'm back now. What's interesting to see is that the Framebuffer is at full usage nearly at the end. So you can see it's just going up the straight line a little bit deeper than like before, but it just ends. And it's then at like or earlier before at 90% usage. If we do an overlay, it's really easy to see how it behaves differently. So both go quite straight up, but the one with 2 full HD a little bit steeper, and then it just stays at 90%. On the other hand, the GPU is a little bit higher with 2 monitors because it has a little bit more to do, and it has to offload the Framebuffer because it's fully used. One up to you.
Now we come to HDX configuration. The other part, we heard a lot about vGPUs and how the impact may be of a Framebuffer, especially for XenApps. And now we need to have a look at the different configuration options we have in the, for example, in the encoder and frame grabbing and all that stuff in between the server VDA and the endpoint, the workspace app or the Citrix receiver. And can you please click? Okay, so there are different codecs for different use cases, and you need to think about that. One thing in advance, for example, if you're using, for example, hardware encode, which we cover later, it may have impact on how much Framebuffer is used. So if you're alone Framebuffer already, that maybe have an impact, but you need to decide based on your workload what kind of encoding technology you use. So if we're talking about video compression, for example, we're using video encoder to send transient images, videos, animations over the wire, it maybe does not make or doesn't make any sense to have a very high color accuracy. So there are different options in regards to color space conversion, as it's called, RGB to YUV, how the codecs are working. So on the left, you see the chroma subsampling to YUV 420, where color is reduced. There's not that much color included in the compressed image. So you see the artifacts. You can barely read the red on blue or blue on red. In the middle, it's a little bit better. That's H.265 compared to on the left H.264, which is the video codec. And on the right, you see H.264 again, like on the left side, but this time encoded with YOV 444. So no color chroma subsampling, no color is reduced or that much compressed that no one can read it. So if you have, for example, that use case, you need static text, like these hard use cases, blue on red, red on blue, and all that kind of stuff, or light gray and cyan, for example, that may be really hard to read. So you need to choose the right codec and the right encoding strategy for your use case. And I included the policy sets you need to set to get all of these different options, like setting visual lossless, for example. Can you please click, Jan? It should be up here. Okay, there you see the different Citrix policies to achieve what codec is used, what color conversion is used, and all that kind of stuff. It's for your reference included. So you can choose what you need. For example, here's another example of played a video file. As you can see, 2 minutes 32 seconds. And if you have a look at down right section where the total bandwidth usage and average bandwidth usage is displayed, you see 5.3 megabit, for example, and 390, nearly 400 megabit with the encoder H.264 with YOV 420, compared to another encoding strategy. I don't know how much compression the GoToWebinar applies currently, but I can see here on my local monitor no difference at all. So, but this time it's encoded with YOV 444, so much better color and higher contrast and all that kind of stuff. But as you see, the total bandwidth usage down right is going up and nearly 3 times as high as we have with YOV 420. So it does not have any visual impact for the end user, but it consumes 3 times the bandwidth. So you need to be very careful to use the right codec for the right use case here. So there we come to the next topic, which would be hardware encoding, which is, in my eyes, very, very efficient when it comes to that one, because we have multiple things to consider. One thing is you reduce CPU load, because the CPU does not need to do the H.264 encoding in software, for example. You can't even do, or you can't do H.265 encoding in software. You have to do it with hardware. Therefore we need the hardware encoding option. One plus is the reduced latency, and the whole latency chain from clicking on your mouse, sending the mouse click over the wire, processing it in the application, switching or flicking some PowerPoint from black to white, whatever, and then sending it back. It's a whole latency chain. Maybe you heard of Project Photon, which has been developed by NVIDIA with there was a setup where they measured the overall latency from clicking with the mouse until the final image is received on the endpoint. And this reduces latency in the whole chain, and that can be the little add-on reduced latency, which makes it usable for a user. Additionally, as you see here, you from this picture, without NVENC, this time with an M10, it was set up for VDI use case. We tested with the 4Q profile as well, and didn't make any difference in performance from a hardware encode perspective. Of course, we tested that with the M10 as well, and you can see 18% CPU was used on a 4 vCPU machine, and 108 max on memory consumed by the Citrix GFX XE. It's a Citrix graphics encoder, which decides based on the policy set, using software encoding, using hardware encoding, which kind of compression to apply YOV 420/444. And this is something, if you use that one, you can reduce your overall load, your overall memory consumption by using the hardware encode feature, the NVENC feature of NVIDIA, or if we talk about AMD, for example, Rapid Fire SDK can be used to reduce it. It's very important to, if you can leverage it, use it. So we can skip the next slide. I think they are showing similar images for Linux as well. It's more important on Linux right now because the impact is much higher. So you can apply this policy through Citrix Studio or GPOs. There are the same policies. You can select use video codec for compression and then for actively changing regions. And additionally, you need to set use hardware encoding for video codec. And the same goes with full screen, which is the next slide. So you can apply it on both as well. XenApp as VDI supports both technology, and since 7.16, Xen Desktop, or nowadays Virtual Apps and Desktop, but back in the days, Xen Desktop 7.16, there is a new option optimized for 3D workload, which changed some settings under the hood, disables something which is not used in that scenarios. For example, CAD/CAM 3D workloads. It's working all together, and you only need to set these three options to have it enabled and fully working, with reduced latency, lower CPU overall consumption, and so on. Yes. So what you need to consider: different graphics cards, different graphic types, different GPUs, as Jan already mentioned, are or have been built for different use cases, and brings different encoders with it. So, for example, if you see the P40, two encoders capable of encoding each 13 streams full HD in YOV 420, and other cards, for example, like the M60, because it has double the GPUs built on the same card, lower amount of streams, but double the amount of GPUs, so it can encode 36 streams. So you need to calculate how many full HD desktops you want to deliver, and take into consideration that different cards have different amount of encoding performance. So that's you can have it there to see what you should use.
Sorry, so before we continue with the next point, there are 2 points from the questionnaire I would like to grab up, both from Tobias. Tobias said one important lesson learned is that typically the Framebuffer capacity runs out before the GPU itself saturates, meaning in many cases that having lots of Framebuffer can be an important factor in choosing which GPU to make use of. And I can fully agree with it. It's a little bit different in high-end CAD environments, where I've seen one user using 8 or 16 gig of Framebuffer, but if you have normal use cases, no, sorry, it's the same there, because one user can easily consume the Framebuffer for a whole graphics card and only use like 20 or 30% of the GPU itself. And Tobias brought also, sorry?
Absolutely, it's totally fine. Yeah.
And Tobias brought up one question which I would like to bring to you. So he asked if U444 is still not supported under Linux.
it should be supported in hardware encoding only, because the performance is, in my eyes, not good enough in with software encoding. There's another problem with 444 on the decoding side, because we don't have any hardware-based decoding on the endpoint with Linux, if you would talk about Linux endpoints, for example. On the other hand, I don't recommend currently, with all the current versions of virtual apps and desktops, because there's, in my opinion, a better option, which is built to lossless, which has been completely rebuilt in 7.18. So in my opinion, in my eyes, it's the best to use YOV 4.2.0, so visually lossless not enabled, and only the last frame, so the build to lossless, the last frame when an image is not moving anymore, is then an overlay of an 2D RLE, run length encoded lossless frame, which is crystal clear, pixel perfect, and that would be my choice today.
So one point to add, if you're working with the Linux VDA, the Linux VDA made a good progress in build to lossless, and lossless modes are in the latest releases 1909. And there will follow other improvements in the next releases. So if you're really using them, I can just heavily suggest you to use the current versions, as there are massive improvements in this graphics area.
Yeah. Another thing I'd like to add here, I've actually never seen that the encoder was the limiting factor here with NVENC, not with H.264, not with H.265, although that may change if more 4K or Ultra HD monitor setups will come into play. Then it may be a factor, but with all my tests and on all our tests, our joint tests with Hendrik and a big banking customer in Frankfurt, the encoder was not the limiting factor. It was still, in fact, the frame and the amount of frame buffer.
So let's head on to H.265.
Okay, yeah, then we'll head over to H.265. So can you please click next? So H.265 is a successor of H.264, and you get higher visual quality if you estimate around the same bandwidth, or you get same visual quality with lower bandwidth consumption. So I'm not a fan of hard numbers, but there are some measurements up to 40% less bandwidth. In my test, it was only up to 25% less bandwidth, but it's significantly. The higher the resolution gets, so with Ultra HD or 4K monitors, it's much better. What you need to know about H.264 and HDX is that you will need hardware encode. It's not doable without hardware encode. As well on the server side, on the server VDA or workstation VDA, as well on the on your endpoint. That's one thing. Unfortunately, it's a Citrix Platinum or Premium feature and included in Citrix Cloud licensing. It's not working with Maxwell Generation 1 cards like the M10. So you can have a look at the NVIDIA site website where NVENC is covered, and you see all the different encoding and decoding options for NVENC and NVDEC, and you see M10 cannot use it. You can check it, for example, with NVIDIA SMI, with the encoder sessions option. You can see it in HDX monitor. You can use RD Analyzer, the remote desktop display analyzer, which will show you which encoder is used. And yeah, that's pretty simple to get to know if it's currently used, how much latency is introduced into the frame grab and encode. It's really nice to see that it's working good. And a lot of customers who are on premium or cloud licensing are currently using it with the newer Pascal Turing cards. So, okay, here's another table, again, for your reference to see which kind of encoding options you have. For example, for the Maxwell, as you see, don't know why it's a little offset. With a Tesla M10, not able of doing H.264, not even in YOV 4.2.0. So yeah. So the difference in scalability, yeah, there is a different scalability between H.265 or HEVC, high efficiency video coding, and the H.264 variant, HEVC. As you can see in the table down below, there are different presets we can trigger. Low latency, high performance, and low latency, high quality, for example. And if you, yeah, there's the overlay of the second generation Maxwell, for example, 410 frames in H.264, compared then it's now the Pascal ones, 554 to 421. It's a little less. But in my, as I told you, in my experiences, that was not the limiting factor. But pay attention, you can monitor it. You can monitor the load. For example, in the vGPU profiler by Jeremy Main, a very, very cool tool to see how much Framebuffer is used, GPU load, CPU load, memory, main memory, and even NVENC and NVDEC, so the NVENC coder. You should have an eye on that if you get to 4K or higher, dual 4K setups, for example, then it might be a problem with H.265.
So one last point we would like to cover is there are a lot of free stuff around in this area that you can use to monitor the environment and have a look. First of all, there's a classical HDX monitor, which shows you a lot of values like the provider of the graphics cards, virtual channel priorities, and stuff like that. Next to that, you have the awesome remote display analyzer, which shows you the encoder type, hardware encoding app, and if you're using a graphics card, you also get some graphics card details like GPU utilization. And if you take our paid version, you can even switch during runtime for your session the used codec types. Next to that, there's GPU-Z, and the one mentioned, the GPU profiler from Jeremy Main, which is one of my favorite tools in our environments to have a look at our usage of the VDIs itself. So you can easily see in a VDI how does it behave, what is used, or how is it saturated. Next to that, there's of course a connection quality indicator from Citrix, which gives the user a kind of feeling how his connection is. And last of all, there's also the DXVA checker to see possibilities. So we now have some time for questions. There are few ones inside the question pane that I still would like to pick up. Julian asks if we see disadvantages in preferring a server VDI than Windows 10 regarding vGPU, or do you always prefer Win 10 as a CAD VDI? Well, and especially that last part, the CAD makes it interesting. If you have users which are not high-end users, I'm fine with taking the virtual apps world, but high-end users have often requirements which you can't fulfill with virtual apps server. Why? Because one user can easily fully saturate the Framebuffer of a graphics card and a CAD environment.
Yeah, please let me jump in.
Sorry.
Please let me jump in. It's about the server VDI. If you're installing the workstation VDA on top of a server operating system, it's not about, in most cases, as I've seen it, it's not about performance at all. It's about licensing, because SPLA, service provider license agreements, not available for Windows 10. So to my knowledge, there are no negative impacts if you install the workstation VDA on top of a server operating system to do a one user workstation based on a server OS, because it's one topic we have over and over again here, based on licensing for service providers and all that kind of stuff, want to have a different licensing option.
I think you need to divide between classical virtual apps users or workload with multiple users on the system, or single users of a system.
Absolutely, so, and that's why he asked, I think, preferring server VDI than Windows 10. So just to, if I get it correctly, so maybe I'm wrong on this one, but he stated all the disadvantages preferring server VDI than Windows 10. So yeah, but as you said, it's true. Going with a multi-user versus single user on a server operating system is a huge difference, because the whole architecture is different, with all the off-screen buffer for the remote desktop session host role inside Windows Server. But this will change a little with all the Windows 10 enterprise virtual desktop stuff as well. So when we come to cloud and all that, but it's another topic.
Vijay asked if there's a more detailed guide for endpoints which launch vGPU session hosted on XenApp and desktop. I think the most important part is if you consider to use H.264 or even H.265, which makes it much more complicated, because a lot of clients or older clients can't decode the stream in hardware and then falls back to software, and they are not powerful enough to properly decode them. So with H.265, most clients are fine with decoding it. But if you switch to thin clients, which are often not this powerful, you need to look if they are powerful enough to do the decoding for H.264 or especially H.265.
Yeah, if you want to use a thin client, there's the HDX Ready program, which tests a lot of that use cases with all the HDX possibilities, and you should stick to the high-end premium HDX endpoints. So another question which is up here: when will Citrix come with H.265 YOV 444 support? That's something we can't deliver alone, because we are dependent on the graphic card manufacturers, and currently there is no hardware decode support, which we need for H.265 for YOV 444, even from NVIDIA. So I don't know any card which do hardware decode, so the NVDEC options of YOV 444. So we can't support it, because H.264 is always hardware encode and hardware decode. This question was from Stick. Hopefully it's answered.
One other point Vijay brought up is the question if you can run VMs with mixed profiles on one host. So the important point is you can run VMs with mixed profiles on one host as long as they are not running on the same GPU. So if you have like an M10 with 4 GPUs, you can run 4 different profile types. If you have just one T4 with 1 GPU, you can just run one profile type.
So, okay, Alexander asked, what about using one of these cards in the physical server? Any recommendations? You need to be careful about that. Not all cards are certified by the OEMs in each server using physical installation, not using a virtualization layer hypervisor in between. So at least for server or for the XenApp role on a server, on a bare metal server, it does not make any sense to have a dual GPU or a multi-GPU card built in, because the RDSH will only use the first GPU available in the system for all DirectX requests, something different for the OpenGL request. We can share that, or we can round robin that, let's call it that way, for OpenGL calls, but not for DirectX. So for DirectX application, will always leverage the first GPU, and if you have more than one, the other one will just idling around. So it does not make that much sense in an M60 or M10 in a physical server. Maybe T4 or P4 or single GPUs. Yeah, you can use it, but always make sure you read the documentation and the OEM specification about using it in virtualist environments or in pure physical installations.
So I think that it's Steph, we're at the end of the time. If you have any other questions, feel free to reach out to Ron and me on Twitter, LinkedIn, email, whatever you prefer. And thanks again for joining and listening, or even if it might be late, like for us today, for you.
Thank you guys. Appreciate everything from today. I want to just point out to everyone that I put a few links in the chat window for you. Those are some extra resources that Jan and Ronald provided to me that might be helpful to you. I'll also include these in an email that goes out tomorrow with a link to the recording, so you'll get those again. Also in the chat window for you is a link to a survey that I mentioned earlier. So it's short and anonymous. We just like to get your feedback. And finally, we just want to remind you to follow us on Twitter. That's the best way to stay up to date with all of CUGC's upcoming events. We're very excited about 2020. We have lots of things planned for next year, including 9 XL events. Those are our full day technical sessions, so keep an eye out for those. Those will show up on our events calendar. And yep, just want to thank everyone for attending today. And thank you again, Jan and Ronald, for a great presentation. If you guys have more questions, please do visit us at mycugc.org and find one of our discussion forums and put a question in there, and I'll make sure that Ron and Jan see the questions.
Yeah, thanks for joining. Have a great evening, great morning, great day, whatever.
All right, thank you guys. I hope everyone has a great rest of your day, and we'll see you at mycugc.org again soon. Bye.
Bye.
See you. Bye-bye.